All right, welcome to the Explainer. Hey, if you're looking to really get a handle on core programming concepts, go ahead and subscribe to this channel. We do deep dives like this all the time. Today, we're going to crack open one of Python's most elegant and honestly super useful tools, the set.
So let's just jump right in. I mean, have you ever found yourself writing some long, clunky loop just to get all the duplicates out of a list? Or, wrestling with those messy, nested loops trying to find what two lists have in common? Yeah, there's a much cleaner, way faster, and more Pythonic way to handle all of that. So here's what we're going to cover. First, what is a Python set? Then we'll get into how to actually create and change them. After that, we'll unleash their superpowers, the set operations. We'll also touch on some key rules and limitations, and finally, we'll look at some practical, real-world examples. Let's do it.
Okay, first up, what exactly is a Python set? Well, when you boil it all down, it's a really simple but powerful idea. It's just a collection of items that are unique and have no specific order.
The best way to think about it is like a bag of things, with two main rules. Rule number 1, everything in the bag has to be unique, no duplicates. And rule number 2, there's no order. Things are just in there. So unlike a list, you can't say, give me the item at position 3, because that concept just doesn't exist for a set.
So let's break that down into 4 key properties. First, yeah, it can hold a bunch of items just like a list. But, and this is a big one, it's unordered. That means no index, no position. It's also mutable, which is just a fancy way of saying you can change it, add things, take things out. And the absolute most important feature, it does not allow duplicates. It just won't let it happen.
All right, so we get the what. Now let's talk about the how. How do we actually create these things and start playing around with them in our code?
You know, one of the coolest things about sets is how they just handle uniqueness for you automatically. Like if you try to create a set with a bunch of duplicate numbers, Python doesn't complain or throw an error. It just quietly gets rid of the extras. This little feature, it's incredibly handy.
Okay, and here's a classic gotcha for beginners, so listen up. If you need an empty set, your brain might tell you to just use empty curly braces, right? But watch out, that actually makes an empty dictionary. The right way, the only way, is to use the set function. Seriously, burn this one into your memory. It will save you from so much confusion down the road.
Changing a set once you've made it is super easy. To pop in a single item, you use .add. If you've got a whole bunch of items to add, say from a list, you use .update. Now for taking stuff out, you've got a choice. You can use .discard, which is the safe option. If the item's there, it's gone. If not, no big deal. Or you can use .remove, which is a bit more aggressive. If the item isn't there, your program's going to crash with an error, so you got to choose the right tool for the job.
Okay, now we get to the really fun stuff, the superpowers. These are the special operations that turn sets from just a simple collection into a total powerhouse for any Python developer. This is really where sets shine. First up is the union. It's pretty simple. It just takes 2 sets and smashes them together into one big new set that has all the unique items from both of the originals. It's the perfect way to merge 2 groups of things.
And this is where you really see how elegant Python can be. Forget writing a clunky loop, you literally just use the pipe symbol, that vertical bar, to join them. Look how clean that is. It's super readable and crazy efficient.
All right, next superpower, intersection. This one looks at 2 sets and finds what they have in common. It gives you back a brand new set with only the items that exist in both. It's absolutely perfect for finding any overlap. And again, the code for this is beautiful. You just use the ampersand symbol. So A and B just looks at both sets, sees that 2 and 3 are in both of them, and bam, you get a new set with just those 2 numbers. This is fantastic when you're comparing different data sets.
Okay, our next operation is difference. Now this one is directional, which means the order you do it in really matters. It gives you back all the items that are in the first set, but not in the second one. And you can probably guess the symbol for this one. It's just the minus sign. So when you write A minus B, you're basically asking what's in set A that isn't also in set B. In this case, since 2 and 3 are in B, they get tossed out, and you're just left with 1. This is so useful for filtering things out.
So, we've seen how powerful sets can be, right? But it's also super important to know their rules and, well, their limits. So let's quickly go over the things you absolutely have to remember.
Okay, here's the rulebook in a nutshell. First, they're unordered, so you can't use an index like myset for 0. Second, no duplicates. We've covered that.
Third, they're mutable. You can change them. And finally, here's a big limitation. The items inside a set have to be immutable. Things like numbers, strings, or tuples are fine, but you can't stick a list inside a set. The reason is a bit technical. It's because sets use something called hashing to be super fast, and you can only hash things that don't change. That's the key takeaway.
Look, theory is one thing, but let's make this practical. When, in the real world, should you actually be using a set instead of, say, a list? Well, here's the big one we talked about at the very beginning. You've got a list, it's a mess, it's full of duplicates. The fastest, cleanest, most Pythonic way to get only the unique items, just turn it into a set. That's it. One line of code, problem solved.
Okay, picture this. You have a massive collection, millions of items, and you need to check if one specific thing is in there. With a list, Python has to go through every single item, one by one, which can be super slow. But a set? Because of that hashing magic we talked about, it can tell you yes or no almost instantly. It doesn't matter how big the set is. When it comes to checking for membership, sets are the undisputed champs.
And this really brings it all home. Let's say you've got two big lists of user IDs from different systems, and you need to find out which users are on both lists. Instead of some nightmare loop scenario, you just convert them to sets and use that simple ampersand for intersection. It's powerful, it's easy to read, and it's exactly what sets were made for.
So I'm going to leave you with a question to think about. Take a look at the code you're working on or a project you've done recently. Is there a list in there that's really just being used to keep track of unique things? Or maybe a spot where you're constantly checking if an item is in the list? Now that you know the power of sets, which one of those lists should probably be a set instead? Think about it. Thanks for tuning in.